to CityWorks, Oceanside, a series about Oceanside's governance, services, and volunteer opportunities. My name is Diana Wenman, and along with Lynn Hinshaw and possibly others, we are going to be exploring how Oceanside is run, the services it provides, and how you might become involved by volunteering. We are going to explore City Hall in all its various aspects, the police department, the fire department, our beautiful library, Tri-City Hospital, the very necessity of life, water, veteran services, and more. So come along and learn a little more about the city in which you live, Oceanside. Today's show is about
Hi, welcome back to CityWorks. I'm Taylor Balance, and it's my pleasure to speak again with Carrie Dale, the director of the Oceanside Water Department. Today we'll be exploring the process of reclaimed water and why it's become such an important issue in Southern California. Carrie, it's good to see you again. I'm looking forward to learning all about reclaimed water.
Well, and I'm looking forward to telling you all about it.
Good. We'll be examining step by step the whole process of treatment for reclaimed water a little later, but could you please give us a brief overview of what reclaimed water is?
Well, sure. And reclaimed water is not a new thing. Reclaimed water is water that's been cleaned up to a very high level. First started out as wastewater that originated in your home. So think of reclaimed water as the things that you flush down the toilet or put down the sink or your shower water. It eventually goes into pipes that flow to a facility like the one we're at today that cleans the water up to a very high degree and eventually cleans it up so if you were looking at a glass of reclaimed water and a glass of water that came out of your tap, you really can't see visually a difference. It's a little bit of a difference, but originally this reclaimed water originates as wastewater, just like it does in the natural water system, where rain comes out of the sky, it goes through the ground, and we extract it from the ground or from the rivers and streams and clean it up as drinking water. So there's a big process that gets us reclaimed water.
That's very interesting. Why is it so important to develop this type of water?
Well, it's important to develop any local supplies in Southern California. And as you know, Southern California is a very arid region. It's almost a desert, not quite, but it's very dry. There are not a lot of local water sources, and the sources we draw water from are from very far away, from the Northern California Delta area as well as the Colorado River. And to get that water here, we have to pump it up and over mountains and use a lot of energy to get it here. So reclaimed water is one of those supplies that's very easily developed locally. And another great thing about recycled water is that it's considered a drought-proof supply. So in times when we've had cutbacks, when we had a drought a couple of years ago, we asked consumers to cut back on their water use. And reclaimed water is one of those supplies where we wouldn't be asking consumers to cut back because people are always going to be flushing their toilets. It's a more reliable supply than maybe the supplies that are coming to us from the north.
Recycled over, no?
It's recycled over and over, that's right.
What are Oceanside's capabilities for delivering this type of water to its customers?
Well, right now our capabilities are very limited. The plant that we're at right now produces about 500,000 gallons of recycled water every day, and it's used on the Oceanside Municipal Golf Course as well as at the Whalen Lake Bird Conservancy. We've recently been working with a lot of the local agencies that surround Oceanside and touch on Oceanside to develop some economies of scale for our project. So, for instance, we've been working with the city of Carlsbad. They have some supplies very close to some of our borders. In fact, the Ocean Hills area is very close to a supply source in Carlsbad. And so for us to build a pipeline from that supply source to where it's going to be used in Oceanside is relatively simple. So we're expanding on that.
So other water agencies in our area have excess reclaimed water they can sell to us, and how would that work?
Well, we would have to enter into an agreement to purchase that reclaimed supply. And certainly we're designing systems in partnership with those different agencies so that we're not paying to build a treatment plant in every single city or every service area. And in that way we save money, but we also develop those local supplies. So it's a win-win for everybody.
Yes, seems like it. Well, how many grades of reclaimed water are there?
Well, they're in some areas, like for instance in Los Angeles, there's several grades of reclaimed water depending on the type of use. In Oceanside, however, we only have one grade of reclaimed water just because we don't have the varied uses here in the city. It would mostly be used on landscape for irrigation and green belts, on golf courses, and those sorts of things. So one grade to answer your question.
I've read that Orange County, California, adds up to 20% of recycled wastewater to its supply of drinking water. Can you comment on that, please?
Well, I don't know a lot of specifics about the Orange County model. I do know, though, that they're using reclaimed water to replenish the aquifer or the groundwater supply, and then they extract that water further downstream and treat it to a very high level. But that's an example of an agency doing a really good job to develop the supplies that they have locally. And in California in particular, because we are very water constrained, or we don't have a lot of local supplies, reclaimed water use for supplementing our other water uses in the community is becoming more and more important. And statewide, there's a movement to look at using reclaimed water in different ways than we're using it right now. So we may see more and more of that in the future. So I think that's the way, or the trend for water supplies in the future. And so stay tuned.
Okay, we'll do that. How is Oceanside and the neighboring water agencies doing in their quest for government funds and grants to build more reclaimed water infrastructure?
Well, with any infrastructure project, there's always a big price tag, and so we're always looking for opportunities for grants, either at the state level or also in the federal level, to help offset any costs that we might have. And so our consortium of water and wastewater agencies that's partnering together for recycled water delivery is really taking an active role in seeking out those funds that we can. We're very optimistic about some of the funds coming in to help offset some of the costs, and ultimately that helps everybody that's using water.
Yes. Is there anything we residents can do to help in this quest for funds?
Well, certainly I think homeowners associations and larger organizations in the city, it would be helpful to have their support. And we may call on you sometime and ask for a letter of support that might go to some of your federal or state elected officials, and that's also very helpful in terms of getting some of those grant monies.
Good. Can you please take just a minute to talk about the new solar system that's aiding Oceanside's energy needs in the treatment of water?
Sure, and I hope you have time to tour it today.
It's very impressive.
Thank you. Well, we're very proud of it. It's the first solar energy plant that's been installed at a City of Oceanside facility. The solar field is a public-private partnership that the city has entered into. So the way that works is that a private company pays for the installation, the operation, and the maintenance of the panels, and the city enters into a contract with them to purchase the energy that's produced from those panels at a cheaper cost than we'd pay SDG&E for that same energy. So we have leased the land adjacent to this plant for those solar panels, and we're coming up on close to a year with those panels in operation. It's a 1 megawatt facility, and it produces about a third of the power that's used at that plant. So it's green, it's reliable, and it's local, just like recycled water.
Carrie, can you go into the actual process for reclaimed water, what it entails?
Sure, I'd be happy to. First, before we do that, why don't we review or go through how water is treated here at our Mission Basin facility.
Hi, my name is Rosemary Chora, Water Utilities Division Manager for the City of Oceanside. Welcome to the Mission Basin Desalting Facility. I'm going to show you a schematic of our facility and how we operate. So what you can see here on this side is the pumping of water from a variety of different wells. We can have up to 8 wells pumping at one time. The water comes along here and is split into 2 trains. We'll follow this one first. 75% of the water is coming through a pre-treatment system to remove large particles and debris that can come up from a drinking water well. It goes through the reverse osmosis process, and we'll show you that a little more in depth in a bit. Some of the water here is lost to waste, and that contains the salts and the minerals that we're trying to remove. The rest of that water, the permeate, flows through a granular activated carbon facility to remove constituents and further treat the water. From there, the water is disinfected. The chloramination is added into the finished water. The pH is adjusted, and it's sent out into our distribution system. Now, coming back over here, when the water first splits off, 25% of it does not go through the reverse osmosis process, but goes through a green sand treatment to remove iron and manganese, which is naturally occurring, comes down this way and blends with the water that came in from the reverse osmosis system and goes into post-treatment, disinfection, pH adjustment, and out to our customers.
My name is Robert Bostic. I'm a water treatment plant operator with the City of Oceanside, and we're at well number 3 right now at our treatment facility. We pull the water out of the ground from just about 200 feet down, and we pump it over to our pre-treatment facility, and at that point, after that, it goes into the process. Okay, and what we have here is the cartridge filter system, which is a pre-treatment process for the RO facility. What happens is the water from the wells gets pumped over here, and these spiral wound elements, they actually filter out some of the sediment and some of the bigger things that we don't want to get into the RO. And so you can see on the inside, perhaps that it's white on the inside, but you can see the coloring on the outside. And what this is doing is it's designed to stop this sediment from getting into the RO system. And so out here, what we do is we inject some acid to lower the pH to get it ready to go in the RO system also. Okay, we're inside the RO building right now. This is where the process takes place. And you can see out here that we have the 2 pipes. They're stainless steel. What happens is it comes out from the cartridge filters and it gets through the pumps and gets forced into the RO trains. And the separation of minerals and salts from the actual water takes place inside those vessels. Because of the pumps, they increase the pressure. So it forces the water at a molecular level to separate salt and mineral ions. And only the clean water gets out, and then the rest of it's rejected and sent out. This is the permeate line. The clean water that's gone through the process is going to go out through this pipe right here. It's going to be carried out to the back of the building, and it's going to go to our next treatment process, which will be the granular activated carbon. Okay, this is our HMI, and this controls the system here. We can change process parameters. We can monitor real time, all the conditions and everything about the plant. We can see all the information that's updated, every millisecond basically. We're getting fresh information from all the treatment points.
Now, Robert, what sort of education do you have to run this?
I've had some college, but I do my training through the California State Department of Public Health, ALPHA coursework, And so we're required up to our treatment level of our license. We have to do so many hours of training, and we have to do refresher courses. So you don't just go and do the test and then get your license and that's it. You got to stay on top and continue to follow your education and your certification route. So there's always new information that we're given access to.
Thank you. Okay, so we're behind your offices, and where are we now, Robert?
Okay, what we're looking at is the iron and manganese system, and what this does is a simple treatment process where we remove iron and manganese from the water before it gets put into our treated water basin. So what happens is we inject chlorine, and that creates an oxidization which precipitates iron and manganese out of the water, and then the green sand filter actually catches that, and what we do is the water, when after so many hours or after we have a head loss, we'll backwash it, and that will go to a waste basin. But normal operation, we remove iron and manganese, and then that goes over to where the permeate water from the RO system actually goes, so they get mixed together, and we pump that out to the system, and that's part of the treatment process of this.
And part of your removing those items is for cosmetic reasons. And
aesthetically, we're removing iron and manganese from the water to prevent discoloration and staining of fixtures and laundry. It's an aesthetic thing that we're taking care of, and we're preventing that from getting out into the water system.
All right, so here, Robert, we have Rosemary's chart. So where are we in the process?
Okay, in the process right now, we're at the point where the water comes out of the RO system from the building.
RO being reverse
osmosis, yeah.
Yes.
And the water actually gets piped out to the system right here, which is the granular activated carbon. And that removes the volatile organic carbon. The other compounds that we can't remove in that process because it's not designed for that.
Yes.
These are designed to take that out. And so what happens is the water those pipes that go up to the top, it's like rain, it goes through the media, and at the bottom it comes back out on that bottom pipe, and that gets sent over to these decarbonating towers right behind us.
All right, now we're at another noisy place. What does this do?
Okay, this is our decarbonation area, and what happens is the water comes from the granular activated carbon system. It gets pumped over, and it goes up to the top of these towers, and then when these towers, the fans are blowing air from the bottom, the water falls to the top, and that equalizes the pH, and when it comes down here, it gets collected at the bottom in this pipe and goes into our pump station.
Well, Robert and Rosemary, thank you very much for showing us the Mission Basin plant. Robert, anything else that you'd like to add?
I feel like I got put on the spot. No, we operate 24/7. Every day of the year we're here. So, holidays and weekends, there's always somebody that's on duty here that's making sure that we're discharging the highest quality water that we can to our city and our residents.
Well, thank you. I know they're going to start up another well, so we'll let you go. I appreciate you leading us around. Thank you, Robert.
You're welcome.
Rosemary, so tell me, what is the capacity of this facility?
The capacity of this facility is 6.4 million gallons per day. We're actually increasing the area in which we're able to pump with our new 511 pump station. This is just one of the ways that the City of Oceanside is investing in our infrastructure to bring our customers reliable, cost-effective water that is owned and operated by Oceanside employees.
So now you've seen how drinking water is treated, and let me walk you through some of the steps that we take to produce reclaimed water. As I mentioned, reclaimed water originally starts out as the things that you flush down the toilet and put in the sewage. It comes to a plant like this. This is the San Luis Rey Water Reclamation Plant, and we process the majority of the sewage that is generated in the city here. In very simple terms, what happens at this plant is that the wastewater flows into the plant, and there's sometimes some large items that's in the wastewater. It goes through some screens that pull those large items out, and then the process goes through flotation, where things come and float to the top and separate out from the wastewater, and they also settle out in the bottom. It sounds kind of gross, but it's a very effective process. It just works by gravity, and it separates out some of the big things in the waste stream. The water keeps flowing through the plant and is introduced to bacteria as well as air that actually eat up some of the organic matter that's in the wastewater, and eventually goes through some additional processes for disinfection. And some of the last process is a polishing process where the wastewater actually goes through a sand bed or a sand filter and polishes the water to make it ultra clean.
How can this water be implemented into an irrigation system for residents and communities?
Well, the larger part of doing that is really on the city to put in the pipelines that treat the water as well as get it to your site. And then a user would have to do a conversion project, so putting in a system that would be able to separate the recycled water delivery from regular water delivery. We don't want to get those intermixed. And we would work with your business or HOA to get approval from the health department. So there are some approvals that are required. And then you should be ready to go and use the water. And we hope to see it being used in landscaped areas. So if there's a large green belt area, or maybe a large landscaped area in your business park or along parkways. The large soccer fields, sports fields at El Corazon are also going to be using recycled water. So those are the types of areas that we see it being used in the future. So we'll help you along. It's going to be a little bit different than using regular water out of the tap, but we see that we're going to make that process as easy as we can.
Good. Carrie, how do we know that reclaimed water is being used? Is there a way to tell?
Well, hopefully you have worked with our department and we've walked you through that. But if you were just going to take a visual look at the different systems, typically reclaimed water is delivered in purple pipe, and there should be some signage that says reclaimed water being used at this site. I just wanted to mention, too, that reclaimed water has a few challenges with its use, and we would like users to know about them when they're looking into using it. And typically, reclaimed water has a little bit higher salt content than water that you would get out of a tap or potable water. And so we would like to work with users of the reclaimed water in designing their landscape so that the plants that are being used or the grasses that are being used can tolerate the higher salt content. Sometimes that can be a challenge.
Yes. What are the cost savings, if any, to be gained from using reclaimed water?
Well, certainly we know there's a cost to convert the system over from a regular irrigation system. And so we recognize that the costs need to be less than what the potable water costs will be so that users are interested in using it. And right now we're working through setting the rates for reclaimed water. Right now the current rate is quite a bit less than you'd pay for potable water. And as we see the rates continue to go up, just because we're subject to some of the pass-through costs from Metropolitan as well as the San Diego County Water Authority, we see reclaimed water costs holding better than the costs of that imported water supply. So I think there's good news on the horizon for users that are very interested in using this very reliable supply in the future.
Kari, before we close this out, do you have anything to add?
I just want to add that recycled water is going to be the new norm in Southern California. It's going to be one of those supplies that's going to stay in the region and really get us through times of drought and make sure that we can keep our areas green and irrigated. Yes. So it's here to stay.
Okay. I want to thank you, Carrie, and all the Oceanside Water Department personnel who have been so helpful to the completion of our 3 shows on water. Please continue to watch KOCT for more CityWorks shows on how the City of Oceanside is serving its residents. Until the next time, stay happy and well.
So in our primary tanks, what basically happens, we have all the solids will settle to the bottom, and those that will float will also go to the top. The solids are removed and sent off to digestion. From there, the water travels to these tanks here, where everything happens. It meets our mixed liquor, where the biosolids meet the water, which will clean the water and make it clean.
And this is where the microbes get introduced?
Exactly. All the microorganisms are introduced at this point. Here we are at the aeration basins. What happens here, the water that has come from the primary clarifier should hopefully be just water. Here's where we go ahead and introduce air and our microorganisms. Here we have a sellability test. Operators do this at least once a day. What we hope to do with adding the right amount of air for the microorganisms, that they will settle well. Here we're mimicking what will happen in our final clarifiers, where we will again settle all the microorganisms, separate them from hopefully what should be then our clean water. So that's what does an operator do here. Operators have a balance. They're almost like farmers. Now, when the wastewater comes in, it has a certain strength. It's called the biological oxygen demand. Now, as an operator, we need to know the strength of that water with how many microorganisms to put in there. We need to go ahead and add the right amount of air so these microorganisms can clean the water. So it's really quite a balancing act. There's what's called an F to M ratio, food to microorganisms. The food is the wastewater coming in to the microorganisms, giving them the right amount of air so we can have the organisms that will settle out of the water so we can separate the water from the microorganisms. So here we are now at our final clarifiers. After the microorganisms have had enough time to go ahead and clean all the bacteria out of the water, it comes over here to a very calm area where we can separate the microorganisms that can go back into the system to continue clean water from the clean water here. Now this water here will go one of two places. The majority of it is sent out to the ocean. The rest of it will go through, if you see behind me with those purple pipes, will go through a final clarification and also be disinfected for further use out in a bird sanctuary or our local golf courses. Here, well, these loud pumps here are outfall pumps that pump directly out into the ocean. What you see here to my side is our composite sampler. Now this runs 24 hours a day, 7 days a week to test or sample all of our water to ensure that we are sending only clean water out into the ocean. Alright, so what we have here is our final area for our reclaimed water. This is the chlorine contact chamber. Now at either end of the contact chamber, we have chlorine residual testing to make sure we're having a high enough chlorine residual. We also have another composite sampler. It roughly takes about 2 hours for the water to travel from one end to the other, and this water is tested daily to ensure we have a complete kill.
Okay, and so that's the basin, is just a holding basin?
Just a holding basin. From here is sent out to our Wayland Bird Sanctuary or also to our golf course.